All right, here is 8-6 day 1. We are starting chapter 8b, which will be our last chapter. And we're switching gears a little bit to basically a new, it's based on trigonometry, but a different way to plot coordinate points, okay? So here's 8-6 day 1. It says polar coordinates and graphs. That's the name of the different type of coordinates we're going to take a look at. So you can see over on the graph on the right over here, not exactly what you would expect when you say, okay, we're going to plot some points, right? Here's kind of how it works. You use basically the vertex right here is what you would call your pole, okay? And if I were to plot a point like right here, I'll mark them on the graph first, and then I'll fill in the rest of the notes. Okay, that length would be R. The angle we'd have to go from here would be theta. Okay, so the big thing I want you to know is we're still just describing a location. Just like if we were to plot an XY coordinate point, that's all we're doing. Is saying, all right, here's the location of this particular point. Again, R is the length of that terminal ray, and if we were to express that location, we would call it R, comma, theta, right? And you see those two things marked. I'll put the angle in blue, right? And of course, we start from here. R is the distance from what we call the pole, or like the vertex, right? It's almost like you could think of that as the point 0, 0, okay? R is how far away we are from that point, and theta is the angle that we had to take to get there. All right, so if you're plotting them, think about it this way. R would tell you which way to go, right or left. Theta, we would always start at 0. Now to do each one of these, I just gotta zoom in a little closer. We'll kind of do them one at a time. Here's 3:45. Okay, so the way I approach these is I say, all right, right off the bat, I go 1, 2, 3, and I mark there. And then I look at 45 degrees, right? If you want to change these, because they're all in radians, you could certainly feel free to do that. I think it's kind of an interesting mix. Most of the graphs we have on here today are in, they're in radians, but we're working in degrees. But just use the conversion that, pi over 6 is the same as 30 degrees, and you can just convert them that way. All right, so now I got to go to 45 degrees. So I start here and start moving along, and right there. Okay, remember on all these, you're marking a particular point, because polar coordinates are like XY coordinates that we're describing a location. All right, let's go look at B. -3, 120. So R is negative, so it's telling me I'm going to go to the left first. So I'm going to go 3 over this way. 1, 2, 3, okay? And from there, I need to go 120 degrees. So there would be 30, 60, 90, 120, and there's my spot right there. Okay? Get a little bit confusing because it's in radians, but I'm still going off of right? Every pi over 6 is like 30 degrees, okay? All right, first find 4. 1, 2, 3, 4, right? So now when I'm marking that I'm there, okay, basically you can see that circle that goes all the way around, there's a bunch of them, right? You got 1, 2, 3, 4, 5, and then 6 units away from the center. That's like based off your R value. I'm at the one that's 4, so I know I'm going to be somewhere on that circle. The next piece is for the angle to tell me where should I go, okay? Pi over 6. All the way to there. And that's where I am. So technically when I'm plotting that point, the little like kind of arc that I drew for the angle doesn't need to be there, and actually kind of technically isn't. But if you need to mark that to get the point plotted correctly, feel free to do that. That's what I'm doing. All right, back over to 4. 1, 2, 3, 4. Now which way to go? It's the same deal with angles, right? Negative ones would open clockwise, positive ones counterclockwise. We haven't seen a negative angle yet. So I'm going to go negative 3 pi over 4. There's one of them. There's 2 of them. There's 3 of them. So there's my location right there, okay? Good reminder there that tells you to go clockwise. All right, here's a couple examples. You could write the same location in different coordinates, okay? So the first thing I'm going to do with each one of these is plot them. I'm going to put a reminder up here, by the way, that the concept of a coterminal is going to come back. We'll get to that in a minute. All right, so we're 2 to the left. So that's our location right there, negative 260. So if you're playing around at this point, in terms of R, we could do 2 or negative 2, right? You could switch the sign. If you switch the sign, you got to mess around with the angle a little bit. And then for theta, you could do plus or minus 360 and do the whole coterminal thing. Okay, so one way right off the bat, if I wanted to say, okay, R, you're going to stay at negative 2, and I subtract 360 to go to negative 300, that's one other way to write it. That's describing the same, okay? If I switch R over to 2, okay, now I kind of got to think about this a little bit, okay? Because now what this means is right off the bat, I'm going to put this one in red, that I went over here to get started, okay? Whoops, I need to back up a little bit. Negative 2. Then I get to 60, I should have gone counterclockwise. So that's where we were the whole time. It was right there. Okay. So now, if I were to go positive 2, this doesn't follow the whole coterminal thing. I have to think of what angle do I need to follow to get back to that same point. Okay. and that would be 240 degrees. Will get me there. Okay, so either one of those two would do it. It would get you back to the same spot. All right, first things first, let's graph this. So I'm over at 3. And the angle says to go to 2 pi over 3. Okay? Now remember, r could be plus or minus 3. If I wanted to just say, let's keep r at 3, I could go do a coterminal and then say, let's do 2 pi over 3. Let's take away 6 pi over 3, which is 2 pi. So that would work right there. That would describe the same spot. Basically, all that's saying is, start here, and the way it's working out with the coterminal is it's saying then angle-wise go that way to get to the same location. Okay, the coterminal thing works if you leave r the same. Okay, that's a really big thing. So r the same meaning it's 3. I'll give you one more, but I'm now going to switch it and say, okay, let's make r negative 3. This doesn't follow the coterminal because I'm going 1, 2, 3 to the left. Right? Remember, my location is right here. Now I'm thinking this through and saying, okay, what do I have to do to go from there to there, right? I'm moving clockwise, so my angle is negative, and I just have to go pi over 3, okay? So if you take r and you change its sign, you got to play around with it a little bit more, okay? It doesn't just follow, right, the coterminal. That's one way to get one right away, but again, to do that, you have to see that r has to stay the exact same as what it was. If you switch it to the opposite sign, which you can do, then you got to think through the angle. You could go either way. You could do a positive case or a negative case, but really helpful to look at it on a graph and see, okay, what angle do I need to take to get to that same location? All right, the rest of the time in our lesson today is going to be on switching back and forth between rectangular and polar, okay? I'm sure that you were not aware that this was something that you could do, but regardless of that, when I show you how this is done, you'll probably be like, none of those concepts are real brand new or unfamiliar. Okay. That's the same r we've been talking about all semester. Okay. R squared is x squared plus y squared. Looks like a Pythagorean theorem. That's the same r, the same x, the same y that we saw like initially in chapter 6 when we started to really dive into trigonometry. You will see on your graph that you do need to pay attention to what quadrant that you're in, okay? So this is saying you're given a point in rectangular coordinates. That's how you would take it over to polar, okay? Think of it in terms of we have a coordinate point in x and y. We need to get it in r and theta. It's in x and y. We need to get it to r and theta. Here's the opposite. You've got polar coordinates and you want to change them to rectangular, x is r cosine theta, y is r sine theta, okay? So it involves some trig functions and a little bit of the Pythagorean theorem, but it's all not pretty basic stuff that you're going to say in terms of doing those operations. You're probably going to feel like I've done this. Isn't brand new. All right, so I'm going to start by plotting this point in rectangular coordinates. 3 over, 4 up. All right, that is where we are, okay? My goal is to take that point and write it in polar coordinates, okay? Now, it's kind of weird to put polar coordinates on rectangular coordinates, but I'm going to do that here in a minute. This is saying go 3 to the right and go 4 up. What we're saying how far is the distance straight to get there? And what angle would I have to take if I were to take that distance? Okay? So let's start with R. Important to remember in this problem that X and Y is what we have, okay? So I put those into our formula here. We get that R squared is 25. Okay, right off the bat, there's R, right? Because I'm thinking about this in 2 parts, that I need R and I need theta, okay? Worth a reminder here that from the very beginning of the problem, I was saying that 3 is the x coordinate and that 4 is the y. So that's how I knew to put those numbers there. Now I need theta. One thing I know about it is its tangent value is 4 over 3. $53.1. So R is 5. Theta is 53.1. If I were to plot that down here, I would go to 5. And then, remember, pi over 3 is 60 degrees. So I'm going to be just short of getting there. Right about here. Now, if you compare these 2 graphs, right, and look at the point here and here, notice it's in the same exact position, right? We're describing the same point. Do you want to describe it off of X and Y, or do you want to describe it off of R and theta? That's the only difference. All right, we'll do another one. There's the point negative 2, 5. This is another problem where we're going from rectangular to polar. So as far as the method of how we do it, it's going to be the same as the one we just did. Okay, I'm going to follow really, really similar steps. We'll start with R. Just a bunch of number crunching at this point. Remember, R is always positive, so when we take the square root in this case, we don't have to worry about that negative case. That's never going to be our answer. And to get theta, we'd use the tangent value of y over x throw that into a calculator, it'll tell you 68.2 degrees. Okay, 68.2. Okay. Now, problem is going to be, it's not really a problem, it's just a situation I need to address. So we got to pay attention to our quadrant. We need to be in 2. That's going to put us in 4. Okay, we need to be in 2. That's going to put us in 4. If I add 180, that would give us 111.8. And then we're good to go. Okay? Usually if you, end up in the wrong quadrant, typically speaking, 180 is the fix, right? Somehow you are, in 2 should be in 4, in 4 should have been in 2. So you usually adding or subtracting perhaps 180 is the way to fix it, okay? But just think it through on the graph. In terms of the angle that you got from the calculator, what quadrant did it put you in, and where were you supposed to be? By the way, when I graph this, square root of 29 is about 5.4. So I go right in between 5 and 6. I need to go past 90, but I don't want to get to 120. So we're right about there. And again, if you compare the polar coordinate graph down below with the location that I marked to the one up here, you're talking about the same location, as always, right? That's a huge point with polar coordinates that I'm trying to make again and again, is that it does something very familiar to us that it takes in like two-dimensional space, describes the location of something. We're just doing it a different way. We're not doing it off of X and Y. We're doing it off of R and theta. All right, we'll go opposite way on this one. We're given a point in polar coordinates. So R is 3, theta is 30. We need to get it to rectangular. That would look like this. These formulas are pretty straightforward to use. You just plug in R and theta. Really, the only question is, you're going to use a decimal approximation from the calculator or an exact. Okay, that really just depends if you're talking about an angle that's on the unit circle. This first one is exact. Cosine of 30 is square root 3 over 2. Certainly refer to a unit circle there if you need to. Nothing to do to simplify that. That can just be 3 over 2. There's X. There's Y. And we have it converted over to what we would call rectangular coordinates. Here's your X. Here's your Y. The last case over here is going to be a decimal approximation. That just means we'd use the calculator. Would not change anything about how we go about doing it. Here's R times cosine of theta. It says to round it to the nearest thousandth, which would be 2.345. get your y coordinate, it's basically the same formula, just switch that cosine function to a sine. And we get x, and we get y, and we're good to go. Okay? That's all for day 1. To look ahead in day 2, we will get into what it looks like to make some basic little graphs of equations in polar coordinates.